Hey everybody! In this video, I'm going to walk you through the network design for Apigee X Pay-as-you-go using a network architecture called Shared VPC. My name is Miguel Mendoza, and I hope you're going to learn something new today. Before we dive into the Apigee network design, let me give you a quick intro into what is a Shared VPC network, what it allows you to do in Google Cloud, and then we're going to see why it makes sense to deploy Apigee X using a Shared VPC network architecture. So let's go over to the whiteboard and I will try to explain things there. In Google Cloud, you have projects. Let's say you have a project A, and within this project A, you have a VPC network. I'm just going to call this VPCA. And everything within this project, it's all perfectly fine. Whatever VMs you have in there, they can communicate without issues because all those resources are within this VPC. Not only that, as a network administrator, you can manage all the stuff within this project, no problems. Now, let's say that you have another project for a different group within your GCP organization, and this is project B, and this one has its own VPC called VPCV. Now, you have some resources in VPCV or in Project B that you want to communicate with from Project A. How do you do that? One way to do it is to create a peering connection between these two VPCs. And this peering connection allows communication between resources between these two VPCs using private IPs. So far, so good. Each of the projects have VMs and other compute resources that are managed independently by the teams that own the projects. But there's one little issue. The networking team, which is usually centralized in an organization, now has to manage subnets across two separate projects, as well as other resources such as IAM networking permissions. This problem will get worse over time as more groups join your Google Cloud organization. So let's say that you have a new group joining and they get their own project that I'm going to call Project C with its own VPC. And this group has some backend services in here that you want to access from Project A. So you're going to need a new peering connection between VPC A and VPC C. Now, this peering connection, it's only good for communicating between resources in these two VPCs. If I have a VM on VPC V that wants to talk to another VM in VPC C, it's not possible to do so. The VMs over here will not be able to transit through these two peering connections. Instead, I'm going to need a new peering connection between these two VPCs. I mean, this is still not horrible, but hopefully you can see that as your Google Cloud organization grows and you have, let's say, 20 or more projects, it will be very time consuming and difficult for a centralized networking team to manage all the VPCs and all the subnets and all the network security permissions within your Google Cloud organization. Not only that, but there's also a limit to how many peering connections a single VPC network can have. So let's go ahead and redesign this diagram that I have in here using a shared VPC network architecture. First, we're going to get rid of all the peering connections, as well as the individual VPCs in each project. Next, I'm going to add a new project, which is going to host a shared VPC. I'm going to name this Shared VPC Host. Let's add the VPC in here. And I'm going to name it Shared VPC. Once the central project is designated as the VPC host, we can actually share the VPC network with each of the three projects. So let's go ahead and do that for project B as well. And for project C, also, the three projects themselves, they're now referred to as service projects. So we're going to have service project A, service project B, and service project C. Notice that I have shown the VPCs over here with a dotted line. What I want to highlight is that the projects themselves do not own the VPC, but rather the service projects are only network users of the shared VPC. Using this architecture, the centralized network team in your organization is able to control from this one project all the network resources and the associated permissions for those network resources. At the same time, the groups that own the service projects themselves, they're able to maintain autonomy over the compute engine resources that are created in those projects. While this is a great architecture that solves a lot of the problems with having many peering connections, this architecture is still subject to Google Cloud's limits and quotas. Some of them apply at the project level and some of them apply at the network level. For more information on those limits and quotas, I have included a link in the description. Now that we have covered the basics of the Shared VPC network architecture, let's get back to the topic of Apigee. First, let's draw the basic Apigee architecture without a shared VPC. Then we're going to see how we can combine the two of them to make them work. So in Apigee, you typically have what is called a customer project. The customer project is tied one-to-one with an Apigee organization, and there is usually one of these customer projects per software development lifecycle in your organization. For example, you're going to have one for production, one for development, one for QA, and so on. The Apigee customer project also has its own VPC that I'm going to call Apigee VPC, and the Apigee VPC has a peering connection to another VPC that is called the service networking VPC. Now, this VPC is in a project that is managed by Google. You do not have access to this project, and it has a name that you don't even know what the name is. But for this diagram, I'm going to call this the service networking host. And as I said, there's a peering connection between these two. So in addition to the service networking host, there's also another Google managed project called the Apigee Tenant project. Behind the scenes, the service networking VPC is shared with the Apigee Tenant project. And in the Tenant project, it's where the Apigee runtime is actually hosted. Also, the Apigee runtime is fronted by a Google Cloud internal load balancer. Finally, to enable external access to the Apigee runtime through the internal load balancer, you would first create a global load balancer in the Apigee customer project. Then, for this global load balancer to be able to reach the internal load balancer, it needs a network bridge or a proxy that allows communication. So for that, you create a managed instance group of virtual machines that act as a network bridge. Now that we have the basic architecture for Apigee X, how do we combine this with the Shared VPC network architecture? One way to do this would be to create a peering connection between the Apigee VPC and the Shared VPC. But if we take a look closely, we will see that this will not work very well. The Apigee runtime will not be able to reach the backend VMs running in these service projects. That's because there are two peering connections separating them. So the Apigee runtime will not be able to transit through this peering connection and this peering connection to reach the backend services. So here's what we do instead. We get rid of this peering connection, and rather than using a dedicated VPC for Apigee, we share this VPC with the Apigee customer project. Even though this peering connection is showing as if it's going into this project, because this is a shared VPC, it's really more accurate to say that the peering connection is coming here to the shared VPC host. Now, the Apigee runtime, it should be able to communicate with the VMs running in the backend service projects, as it only needs to cross a single peering connection. Now that we have a network architecture that we know should work well with a shared VPC, including Apigee, for the next video, I want to walk you through the process for setting up all of this from scratch. In that video, I'm going to be setting up a shared VPC host, a service project, and an Apigee customer project. Then I'm going to provision Apigee X using the pay-as-you-go model. Finally, I'm going to do an end-to-end connectivity test where I'm going to have a client make an HTTP request to an Apigee proxy that's going to forward calls to a virtual machine that's running in the service project. Well, folks, this is it for the video. If you have additional questions, don't hesitate to reach to me or other Googlers in the Apigee community. There is a link in the description. If you found the content useful and want to see more content like this, make sure to leave a like and subscribe. And I'll see you in the next one.